Hello everyone, welcome to this video. In this video, we are going to solve some of the circle theorem questions taken from the recent past papers. The first question is A, B, C and D lie on a circle, center O. AC is a diameter of the circle. AD, BE and CF are parallel lines. Angle ABE is 48 and angle ACF is 126. Find angle DAE. So we need to find angle DAE, that is this angle. So here it's given ACF is 126. ACF and DAC both are allied angles. That means co-interior angles. Co-interior angles add up to 180. So angle DAC plus angle ACF is 180. So angle DAC is 180 minus 126, which is 54. So this is 54. So then angle DAE is also 54. Next, find angle EBC. So we need to find this part. Okay. And we know angle in a semicircle is 90 degree. So this angle is 90. Angle at B is 90. So then angle EBC is nothing but 90 minus 48. Which is 42. Next, angle BAE. So we need to find this angle. So angle DAE is 54. Okay. So this angle are alternate angles. So alternate angles are equal. So angle AEB is 54. In triangle ABE, we know two angles. We can find third angle by subtracting these two angles from 180 degree because angle in a triangle is 180. Angle AEB is also 54 degree. So in triangle ABE, angle BAE is 180 minus 54 minus 48, which is equal to 78. The next question is, in the diagram PT and QR are parallel. TP and TR are tangents to the circle PQRS. Angle PTR is equal to angle RPQ, which is 38. What is the special name of triangle TPR? Give a reason for your answer. So this is the triangle TPR. Here TP and TR are tangents. Tangents which meet at the same point are equal in length. So these two tangents, that is a TP and TR, are equal in length. So in a triangle, when two sides are equal, it is known as isosceles triangle. Okay. So the name of the triangle is isosceles triangle. The reason is tangents which meet at the same point are equal in length. So the next part of the question is calculate angle PQR. So we need to find this angle. To find PQR, first let's calculate angle at TPR. Because the triangle TPR is an isosceles triangle, angle at TPR and TRP are equal. So if we take this as x, 2x plus 38 is 180. Angle in a triangle is 180. So 2x is 180 minus 38. So x is 180 minus 38 divided by 2. So which is 142 divided by 2, which is 71. So this angle is 71. So this is also 71. It is given that PT and QR are parallel and PR is a line which cuts across these parallel lines and creates two equal alternate angles. Here TPR and PRQ are the alternate angles. So angle at PRQ is also 71 degree. In triangle PQR, we know two angles, 38 and 71. The third angle can be calculated by subtracting these two angles from 180. 180 minus 38 minus 71, which is 71. So angle PQR is also 71. Next, find angle PSR. So we have to find this angle. PSRQ is an cyclic quadrilateral. So opposite angles add up to 180 degree in a cyclic quadrilateral. So angle at S is 180 minus 71, which is 109. The third question is, the points A, B, C and D lie on a circle center O. Angle AOB is 90 degree, angle COD is 50 degree and angle BCD is 123. The line DT is a tangent to the circle at D. Find angle OCD. So we need to find angle OCD. So this part. So here O is the center. So OD and OC are the radius of the circle. So OD and OC are equal. So triangle ODC is an isosceles triangle. If you take this as x, then this is also x. So 2x plus 50 is 180 because angle in a triangle is 180. So 2x is 180 minus 50, which is 130. So x is 130 divided by 2, which is 65. So this is 65. Next, find angle TDC. So we need to find this angle TDC. We know the angle between the tangent and the radius is 90 degree. So this is 90. In that ODC is 65. then angle TDC is nothing but 90 minus 65, which is 25. So this is 25. Next, find angle ABC. So this is the angle ABC. To find the angle at ABC, first let's calculate angle ABO, this part. So here angle AOB is 90 and OA is equal to OB because both are radius, is an isosceles triangle. So these two angles are equal. Okay. So what is that angle is? 180 minus 90 divided by 2, which is 45. So this is 45. So let's calculate OBC, this part. And it's given the total angle is 123. And in this part is 65. So what is the value here? 123 minus 65, which is 58. So this is also 58 because this is an isosceles triangle. So these two angles are equal. So angle ABC is nothing but angle ABO plus angle OBC. So this is 45 and this is 58. Adding, we get 103. Next, find the reflex angle AOC. So this is the reflex angle. Okay. To find the reflex angle of AOC, first let's calculate this part. Okay. So here in the triangle OBC, we know the angles 58 and 58, two angles in a triangle. So what will be the third angle? 58 plus 58. If we subtract this from 180, we get the third angle, which is equal to 64. So angle at a point is 360. To find this angle, we have to subtract 90 and 64 from 360, which is 206. The next question is, here AD is the diameter of the circle, angle BAC is 22 and ADC is 16. AB and ED are parallel lines. Find the value of W, X, Y and Z. In triangle ACD, angle in a semicircle is 90. So this is 90. Angle in a triangle is 180. So W is 180 minus 90 minus 60, which is 30. Angle in a same segment are equal. So W is equal to Y. W is 30. So Y is also 30. Next, this and this are same segments. So angle in a same segment are equal. So x and 22 are equal. So x is 22. The line AB and ED are parallel. These two are alternate angles. Okay, so here W is 30. So this total angle will be 30 plus 22, 52. So this is also 52. The diagram shows a cyclic quadrilateral. Find the value of P. In a cyclic quadrilateral, opposite angles sum up to 180 degree. So here 4M and 5M are opposite angles. So this is equal to 180, and P plus 4M plus 38 are opposite angles whose sum is 180. So 9M is 180. That means M is 180 divided by 9, which is 20. So substitute M as 20. Now make P as the subject. So 180 minus 80 minus 38. So P is equal to 60.